Now the problem can be not just two resistances, but it could be even more. So, for example, if you have a circuit system something like this one, all kinds possible, you can think about all complicated circuit. Let us say you have like this, and then you will have node number 1, 2, 3, 4, 5, 6, 7 for example. So you have 7 nodes. So accordingly you will have currents coming here. You will say I1, this will have I3, yeah. Here if there is a current coming from outside, you will call it I4. Is a current coming outside here, I5. This will be I2 for example. Any current coming here to this node, say I6, and any current coming to this one, I7. Yeah. So what you see here is the current coming to any node is taken as positive, and hence there is a lot of possibilities. You can supply current, external current here also or here also. Yeah. At the ends there is typically a compulsorily there will be a current coming. Yeah. So for here for example, or here or here. Yeah. Okay. Now registrations also, let us say this element number 1, so is R1, you can say this is R2, this is R3, R4, R5, R6 and R7. So what you see here is 7 elements. So 1, 2, 3, 4, 5, 6, 7. So 7 elements, and number of nodes is 1, 2, 3, 4, 5, 6, 7. So you have 7 nodes and 7 elements, and hence the size of the matrix will be 7 by 7. Yeah. So you have 7 currents I1 to I7. You have accordingly you will have voltages as well. So so you will say you have V1, V2, V3, V4, V5, V6, V7, and you will formulate, you know, the connection, and accordingly you are going to formulate it. Yeah. So we are not going to solve this one, but it is just to show that problem could be complicated, still you should be able to solve them. There is no difference. So what you have to see is how they are connected. Say if it is connected, for example, this point is connected to this and this and this, hence in the matrix there will be addition at a particular, say let us say at K22 position, there will be component because of this one, because of this also, because of this also, all connected together. We will study more when we proceed. Okay. But here the idea is to tell that based on what we learned, we can even solve this one given either I1 is known or V1. So everywhere one of them should be known, either you know the I2 or V2, but not both. But you have to know one of them. Okay. Similarly here either you know V5 or I5. If there is no, it's not this point is not connected to external system, then I5 will be 0, yeah, and so on. So let us look at little bit simpler example. So, let us say we have this star kind of problem like this one, right. Okay. And you see the connection here. So, let us call it 1, you have 2, then we have 3 and we have 4, and current coming to this one will be known as I1, any current here, I2, then this as I4 and this as I3. Okay. Let us assume in our problem this is I1 is asked. So, we have V1 equal to 0, we do not know what V2 is, yeah, okay, and let us make one more, this also 4 also we are going to earth it, just to make it simple, that way it easy to solve them, yeah, because it is going to be 4 by 4 matrix, because you have 1, 2, 3, 4. So, we have to invert it. So, once we make 0 here, then we have just 2 nodes, we have to find out V2. So, that way it is easy to invert, that is why I did, otherwise not necessarily it had to be b equal to 0, you do not have to put. Okay. So, just to make it simple, but here just idea is to show you the kind of possibility. So, we have V4 is equal to 0, we do not know V2, we do not know V3, yeah, okay. Now, here we know V, we do not know what I2, I1 is, because we have already defined V1. So, I1 we cannot define and we do not know, we have to find out. Here V2 is not defined. So, I1 has to be defined, either we should know what is I1 coming to this one. So, let us make it we assume I2 equal to 0, means it is not connected to any outside circuit, yeah. So, connection is just these 3 connection only, there is no such connection this one. So, in that case basically that really means that there is no external connection, means I2 equal to 0, hence you take is equal to 0. Okay. Now, similarly here I3 again, since we want it to be a delta connection, but we do not want to make it the I3, we do not want to make it equal to 0, but we will get some okay, we have already given some voltage V4 and V3. So, we want to make it also simple, we cannot make it V3 equal to 0, otherwise it will be all will be 0 only, so it will not work. So, let us say we are giving some value of I3 here. Okay. So, let us make it I3 in this case is equal to 5 ampere. Okay. I3 equal to 5 ampere and we do not know what V3 is. Okay. This is 5. Okay. So, this is a problem we want to solve. V1 equal to 0, we do not know, I want to find out I1. Here I2 equal to 0, we want to find out V2. Okay. Then here I3 equal to 5 ampere, yeah, but we do not know what the V2 is. Here V4 equal to given 0, we do not know I4 is, yeah. So, here I4 will be basically whatever is coming going from the, so basically I4 in this case will be actually I should have earth like this. It should be this one. This is the I4 basically. Okay, so just take it. Okay, so wherever earthing is, from there the current will be going. Okay, so here I4 is, we don't know what the I4 is. Okay, but we know the V4. Okay, so basically here only we can make force vector. Force vector, you know, force vector is the current basically, will be I1, I2, I3, I4, and which is equal to I1 we don't know, we write I1, I2 here is 0, I3 is 5 ampere, which is coming, it is into the system, so 5, so let us write 5 here, I3, and I4, okay, so I4, this one we don't know, we have to find out. Yeah, so we write I4 here. Okay, done. Now we can also write here the displacement vector, which will be equal to, okay, so displacement vector will have V1, V2, V3 and all. So V1 is equal to 0, so we write 0. Then we have V2, we don't know what it is, so we write V2. Then we have V3, we don't know that, so we write V3. And then we have V4 equal to 0, so we write V4 equal to 0 like this. So this is our displacement vector. Okay, now we have to find out the stiffness matrix for this, and for that let's assume we have resistance 1 ohms. So we have 1 ohm, when we have 2 ohm, and here we have 4 ohms like this one. Okay, now let us see. Okay, so we have 3 elements, hence we have to assemble that way, and we are going to do that. So okay, so we have 3 elements. So element number 1, let's name it, this is resistance number 1, or you call it R. This is R equal, this is R1, this is resistance number 1, this is R2, and this is R3. Okay, so this is element number 1 is here, we call it 2, we call it 3. Okay, so this is 2 and this is 3. Okay, okay. So element number 1, this is R1, which is equal to 1, and hence our stiffness matrix, the first one, local element stiffness matrix, what we call, this is for first resistance, so which will be 1 over R1, and then we have 1 minus 1 minus 1 1. Yeah, so this is simply 1 minus 1 minus 1 1. Then we have K2 is equal to 1 over R2. Okay, and then 1 minus 1 minus 1 1, where R2 equal to 2. Yeah, so 1 over 2, 1 minus 1 minus 1 1. So of course this is per ohms talking about, and then K3 again, if you see, has 4 ohms. Okay, so stiffness matrix in this case will be 1 over R3, 1 minus 1 minus 1 1, and which is equal to 4, 1 over 4, 1 minus 1 minus 1 1 ohms. Yeah, and then we have to combine them together. Okay, how we have to write the we have local numbering here, right? Local numbering means this is 1 1, this is 1 2, this is 2 1, this is 2 2, right? So 1 2 1 2 is local. Here also 1 2 1 2 is local numbering, 1 2 1 2 is local numbering. Okay, now what we have to do is write the global numbering there. So the first one has, this is 1, this is 2. So 1 2 is the first one. Second one has 2 and 3, and third one has 2 and 4. Yeah. So 1 and 2 first for the first one. So just we will just write it so that we remember. So for first one we have 1. So we have 1 2 1 2. Yeah. Okay. For second one, second element, we have 2 3. So accordingly we will write, we have 2 here, 3 here, 2 here, 3 here. Okay. Now third one, we have connection between 2 and 4 node. So we write 2 and 4. So we have 2. So first one is 2 and then 4. Accordingly we have 2 and 4. So from here we have now K1, it will go to K11, this will go to, this is K11, this will go to K12, this will get to K21, this will get to K22, and similarly all of them. Yeah, so we know that. Okay. So now we have to combine from all these three into the big K, that is the global stiffness matrix. These are the element stiffness matrix. So we can write it also. These ones are element stiffness matrices. Okay. So we will assemble the global one next. So the big K is going to be, we will write, let's make it bigger, and then we write here 1 2 3 4, similarly 1 2 3 4, so that we can add them nicely. Yeah. So we have like this. Okay. Then let's go back and see what the values are. Okay, so we have 1 1. If you look at 1 1, only this has 1, no other, we have 2 3 2 4 2 4, only 1 1 is only here, only the value is 1, we just simply write equal to 1. Okay. Now we let's go row wise. So first 1 1, then 1 2, then 1 3, then 1 4. So now we want 1 2. Okay. So row numbering, this is 1, this is 2, so we have minus 1. No other places we have 1 2 combinations, only here only. So we have 1 2 1 2. We can also write like this. Actually we say this is 1, this is 2, this is 1 and 2, and you know that 1 minus 1 minus 1 on 1, and if have 1 here, 2 here, 1 here, 2 here, I will just write 1 minus 1 minus 1 1 here. So what you see here, look, 1 here, 2 here, 1 here, 2 here. So, local and global both are the same number. So, we can just transfer directly. We can write 1 minus 1 here, minus 1 1 here. Why? Because local and global number are the same. So, we just write it like this. Okay. Now, next one. So, this we have completed. Now, this one is we just write these things in 2 3 2 3, right. So, this is the, as long as in the global one we are writing in 2 3 positions, that's fine, right. So, that means 2 2 here, 2 3 is here, 3 2 is here, 3 3 is here, yeah, but this is half, remember, yeah. So, accordingly we write. So, 2 3, right, this position is 2 3. So, 2 3 is here, 2 3 is here. So, basically this is the location where we have to write this one 2 3 2 3, hence location is this. Hence, we are going to write. So, let me write in blue color denoting the for the second element. So, this is the 1 plus half minus half minus half half. This is coming from the second element. Okay. Now, look at the third one. So, we have finished 2 3 2 3. Now, 2 4 2 4 means local 1 is global 2, local 4 is local 2 is global 4, local 1 is 1 means row 1 row 2, local 1 is global 2, local 2 is global 4. So, 2 4 2 4. So, we have to put this as 2 2 position, this as 2 4 position, this as at 2 4 2 position, this at 4 4 position. Okay. So, we will accordingly we will put that. So, let us put in this different color. So, what do we get? 2 4 2 4. Okay. So, not to forget 2 4 and 2 4. So, we have 2 4 2 2 4. So, location is 2 2 this location, 2 4 this location, 4 2 this location, 4 4 this location. Okay. So, accordingly we will write here it will be again 1/4. Remember we have 1/4 we have to write. Okay. So, we have to write here it will be plus 1/4 minus 1/4 minus 1/4 plus 1/4. This is what our estimation matrix is. All other places we have to put zeros. Yeah. So, basically we are going to, okay, let us put that in red color. So, all other places 0, wherever is empty we will put 0 right there. Okay. So, what you see symmetric basically, yeah. So, it will be always symmetric, yeah, and hence the determinant will be 0, okay, and has to be 0 as I said earlier, because you apply boundary condition then only you can invert it, otherwise you cannot. Okay. So, this is what your stiffness matrix looks like. We can add them and we get finally k equal to, we get 1 minus 1 0 0 minus 1, and then you have 1 plus 1 over 2 1 over 4. So, we get 4 and 2 6 x 7 7 over 4. So, we write 7 over 4. Okay. Then we have minus half minus 1/4 0 minus half half 0, 0 minus 1/4, 0 1/4, and this is what you have the stiffness matrix. Okay. So far which all things we have? We have F vector, we have U vector, or we have a stiffness matrix. What we have to do is simply solve them. A stiffness matrix, our equation is basically going to be Ku equal to F. So K will multiply with this one, and you know that this row and this row are have 0. So we can write actually. So okay, so let's write it. So our equation, we will write the equation. So our equation is Ku equal to F, where K is equal to 1 minus 1 0 0. So let's write it. 1 minus 1 0 0, minus 1 7/4, minus half minus 1/4, minus 1 7/4, minus half minus 1/4. Okay. 0 minus half plus half 0. 0 minus half plus half 0, and 0 minus 1/4 0 1/4. So okay, 0 minus 1/4 0 1/4. We can also check whether it is symmetric or not. This will tell whether it's correct, whether we made any mistake in copying. So we see here all symmetric, here symmetric, here symmetric, here, so fine. Okay, so have to multiply with u, and what we have. So look at this, u have 0 v2 v3 0, 0 v2 v3 0. Okay, so just let's write it. 0 v2 v3 0 is equal to, we have the force vector, and force vector is here I1 0 5 I4, I1 0 5 I4, I1 0 5 I4, I1 0 5 I4. Okay, this is the equation we have to solve. Okay, so here what we have, 0 will multiply with this row, right? This 0 will multiply with this 0, this row, sorry, this row mean column I mean. So so what happens is this cancels out, this cancels out. Yeah. Second thing is we have I1 here, I4 here. Even if, so this is not good, because we have to find out v2 v3. So we don't need basically this one. So we don't need first row, we don't need the last row. There is no meaning of first column and last column. Our equation is simply this portion multiplied by this equal to this one. Yeah, so this is what it will turn out. You can do yourself also. 0 multiplied by minus 1 is 0, hence 7/4 multiplied by v2 minus half multiplied by v3 equal to 0. This will be the first equation. Second equation will be 0 multiplied by 0 no use, minus half multiplied by V2 will be the 1, plus half multiplied by V3 will be the 1, 0 multiplied by 0 no use, then u equal to 5. Yeah, so these two equations basically, or simply we can write here, okay, 7 over 4 minus half half multiplied by B2 times B2 V3 is equal to 0.5. So, this is the equation we can solve by inverting, and we can write V1 V2 V3 is equal to, let us invert directly. So, will be half, then half 7 over 4. So, what we did, we interchange this one and remove the negative sign from these two. So, this is how you invert, and multiplied by the divided by the determinant. Yeah. So, and multiply, let us multiply this 0.5 and divided by the determinant. Determinant is 7 7 over 8. Yeah, so we have 7 over 8 minus 1/4. Yeah. Okay. So finally, what answer we get? We get 0 multiplies to half, hence only multiplied by 5 is the 1, that is useful for us. Okay. And what is the value here? This will be 7 minus 2 divided by 8 equal to 5 over 8 is the thing, right. Okay. So, we get simply V2 V3 equal to V2 V3 is equal to, here we have this multiplied by 5, so 5 over 2, and this multiplied by 5, so 35 over 4. So, 5 over 2, 35 over 4. So, 5 over 2, 35 over 4, okay, and divided by here we computed 5 over 8, right. This was determinant was 5 over 8. So, we divide by 5 over 8, okay, and simply what we get is 8 over 5 multiplied by 5 over 2, 35 over 4, and we get answer is equal to, we got 4 here. So, 5 cancels out, we have 8 divided by 2 equal to 4. In this case we have 5, 7 here, and 2, 4, 2 is 8 here, so 14. So, what we get is 14 here. Okay. So, this is the volts we got. Yeah. What it tells you is 4 and 14, V2 V3 4 and 14. So, V2 V3 4 and 14. Okay. So, V2 is 4 volt and V3 14 volt. Okay, that's the what answer we got. Okay. 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 Then we have to find out, given this, now we have found out voltage V2, what is the voltage here, and we found out voltage here and here. Okay. accordingly we have to find out all the other currents. Okay, so we go back in the final equation we have. So if you look at here now we have 4 and 14 here. So we put these values and we get I1 and I4. We just multiply this times this, we get I1, and we multiply this to this one, you get I4. So this multiplied by this is this multiplied by this is this. So here what we see here is this multiply 0 multiplies to 1, V2 multiplies minus 1, V3 multiplies to 0, 0 multiplies to 0. So only minus V2, what do we get? We get 0 times 1 minus V2 equal to I1. We get I1 equal to minus V2 simply, right? Okay, so just we will write I1 equal to minus V2, yeah, minus V2 is 4, so you get minus 4, you get in ampere. Okay, remember I am writing units here, but all these things are not necessary, because we are whatever you give input, accordingly the output comes out, and accordingly if you are following, for example, all inputs in SI unit, you output also get in SI units only. Okay, so you no need to write, but still I am writing here, yeah. Okay. Then we have I1 is known here. I1 found out by multiply by this and this, which comes to be minus 1. I1 equal to minus 1 multiplied by V2 minus V2. So I1 equal to minus V2, where minus V2 is 4. So we get minus 4 ampere. Second thing, we have to find out I4. So this multiplied by this, and similar situation here, 0 multiplies to 0, minus 1/4 multiplied to this V2, 0 to V3, 1/4 to 0. So minus 1/4, yeah. So the minus 1/4 multiplied by V2 is equal to I4. I4 equal to V2 minus V2 over 4. I4 equal to minus V2 over 4. So I4 equal to minus V2 over 4. So we get minus V2 is 4 divided by 4 equal to minus 1 ampere. Okay. So I1 equal to minus 4 ampere and I4 equal to minus 1 ampere. Okay. Remember, when you say minus, that really means current is going outside of the node. Okay. So I1 equal to minus 4 ampere, I1 equal to minus 4 ampere. So in this case, remember that we are applying, so here this one is the earthing here. So current I1 will be here we are talking about here, yeah. So let me correct it first. So basically we are talking about the I1 has to be here, because this is connected here. So don't be confused this way. Okay. So this is I1. We got the answer as the I1 equal to 4 ampere, yeah. So I1 equal to minus 4 ampere, meaning that current is going outside, current is flowing to the earth, which is equal to 4 ampere, which is going outside, away from the circuit we consider. And then I4 equal to, it says minus 1. So it says I4 equal to minus 1 ampere. So in this case also, meaning that current is not this way actually. Actual current is this way, and value is 1 ampere, or why? Because I4 is positive, which when the current gets into the node, and since you are getting the value minus, that means the current should be outside, like this one. Yeah. So this is the meaning. So this is how we got, so we you can check also, you can check whether it's correct or not, and you know that, for example, here there must be 1 ampere, 4 ampere flowing this through this resistance. That means there should be 4 volt of potential difference, 4 ampere multiplied by 1 ohms, and if it is 0, we should get 4 volt here, and of course V2 equal to 4. So we are getting 4 volt here, right? So it's good. Okay. Similarly here, if 5 ampere is coming from here to here, then if it is 4 volt, then there has to be the like 5 ampere multiplied by 2, 10, potential difference between this and this has to be 10, and since the current flowing from this one, this node has to be at higher potential. Yeah, so 10 plus 4 plus 10 potential difference has to be 14, and hence the V3 equal to 14 volts. So this is correct. Similarly, you can do here, you have a current 1 ampere passing, so 1 ampere multiplied by 4 ohms, that is 4 volt. 4 volt is the potential difference from here to here. Yeah, and you know this is 0 here. Yeah, this is 0 here. So here it has to be 4, and indeed it's a 4 here. So it's 0 here and 4 here. Yeah. So you get automatically, you have validated all of them, your answer as well. So you should always do that whether your answers are correct or not. Yeah. Yeah, so this is how one example from electrical system. We will look at more different kind of system. Remember that our focus will be on the mechanical systems only. Yeah, because this is the core for mechanical engineering students, MTech students. Yeah. Okay. So that is all for today, and in later we will